Hi everyone, quick update video. So for the last maybe 3 or 4 months I've been working on the next iteration of my battery management system. I've gone through a few iterations before which I've never even made it to PCB. So this was another one, totally analog electronics based, and it sounded good on the face of it because obviously with it being analog electronics it's very unlikely to fail, but the problem is when it does fail it will most likely fail in a silent way so that you're not going to know about it until your battery is on fire, which is a bit of a shame. I had all sorts of features like wire break detection. It would output state flag signals for overvoltage, undervoltage and balancing, things like that. Super simple to operate, just plug and play, but unfortunately it's not really good for manufacture either because it has almost 1,000 parts on it. I think I had over 950 parts, and it's 100 millimeters tall, so it's also quite big, and it was just going to be so expensive to manufacture. So I've gone with a microcontroller based design which will retain the exact same functionality. It will still be plug and play. However, it will also have options for advanced users who want to connect via CAN bus and configure and operate it as they see fit. However, you can still just plug it in, supply 12 volts, that will just power up and start balancing the pack automatically. And you might just have a few jumpers on the board just to set the operation mode, and then that'll be it. So that should hopefully be a more effective solution. Obviously, if anything goes wrong with it, it will be more likely that the fault will be detected and the thing could be shut down. So the obvious reservation I've got with using microcontrollers is that I don't know how long the program is going to last in the flash memory, because they don't store the programs forever. You just do not get mass ROMs anymore. Even one-time programmable ROMs, you can't get a hold of them, so it's not ideal. I've been reading up about these, and at the sort of temperatures we get in Scotland, I've been getting figures that from calculations that the program would last maybe 30 to over 100 years. So I don't know, but at least if the program does corrupt, it might be detectable somehow. The microcontroller I'm using does have detections for that, so I could probably just trigger some sort of shutdown when that happens. So yeah, it's not the ideal path I want to go down, but I think it's going to be so much cheaper to manufacture, and there would be even the option for me to assemble it by hand as well, because there's not like 950 components on each board. And if you wanted multiple boards, say you had a 96 cell stack, you just get however many of these you need, and I think I could just have jumpers where you can just automatically address each board and then connect them up by CAN bus and they'll just work by themselves, or just use the simple state flags to a central system. So yeah, nice and simple. And otherwise I've just been sort of working on my little work area here, and this is just a nice desk which I got from my work which I wasn't needing anymore. It's got a power meter here to this socket as well, so I can measure the power consumption of various things, and yeah, it's overall a pretty neat setup. So yeah, I think I should maybe have this design finished in another few months and tested, so after that I'm going to have to get back to working on my drop-in board for the BMW i3 inverter because I need it for my electric motorbike.